I don't think that they would have identified with each other particularly closely. And I think they would have perceived themselves as being in competition.
Such encounters could have occurred all over Europe. What happened next? Did modern humans simply slaughter the Neanderthals? Or was the competition more subtle? Instead of killing them, maybe we were better at finding food. There's evidence that we had a more varied diet than most Neanderthals. Whatever happened, modern humans, our ancestors, won out. Today, it's obvious who dominates the planet. Neanderthals are no more. But anthropologist John Hawkes believes this version of the story is way too simple. He thinks that modern humans were not really so different from the Neanderthals. When they met, our ancestors would have been curious, not hostile.
It would be insane to go out and pick a fight. You're not a military organization going in, looking to conquer. You're a small group yourself. You sort of have to, find a way to live with the locals, and as you do that, you learn from them to some extent. And the locals learn from you. I feel like the defense attorney for the Neanderthals sometimes. I'm trying to see the ways that they overlap with us and trying to add complexity to the story, because any story that involves things happening over a continent, over thousands of years, it's got to be complicated.
How far might the interaction have gone? Instead of making war, perhaps they made love. And the two species exchanged genes. It's an intriguing idea, but very hard to prove. The fossils are inconclusive. The answers lie in DNA. And reading the DNA of a Neanderthal is hugely complex. Even when scientists can extract enough material from a bone like V80, to read it, they have to decipher its entire genetic code. This would be impossible using conventional technology because the DNA is so old and mixed up. They needed a technological breakthrough. This is the backyard of biotech businessman and innovator Jonathan Rothberg. He's built his own version of a prehistoric stone circle loosely based on Stonehenge. It's an astronomically accurate clock that marks the birth date of his children. His son Noah was born in July 1999, but there were complications, and he was rushed into the ER. So began a chain of events that would lead to the sequencing of Neanderthal DNA.
My son wasn't breathing. My son had turned blue. I wanted to know if we could read off his genome, would we know what medicine to give him? Would I know not to worry? Would I know what to do? And that night, I saw a computer magazine. And in that computer magazine was a picture of a new computer chip. And that computer chip had 10 million transistors on it. And literally a light bulb went off in my head. If I could move sequencing to a chip, we could miniaturize it like the computer guys had done. My son recovered. I was on paternity leave, and I spent the next 2 weeks moving sequencing to a chip.
For Rothberg to revolutionize genetic sequencing, he needed to find a way of turning DNA into a digital signal that could be read by a computer. For inspiration, he turned to a childhood memory.
As a kid, I remember that there was actually an animal that would move biological information to something that was more digital. And this might sound nutty, but it's the firefly. We've all watched these fireflies on cold evenings or warm evenings in the summer in New England blink. And using the enzymes from fireflies, I literally devised a system over the next few weeks that would take a letter of DNA and turn it into a pulse of light.
Within a year, Rothberg had patented a new method of sequencing DNA that was 100 times faster than what had come before. And he formed a new company, 454 Life Sciences. To explore the potential of the technology, 454 hooks up with the Max Planck Institute in Leipzig and takes on one of the biggest challenges in genetics, sequencing Neanderthal DNA. In summer 2006, the Neanderthal Genome Project begins. Samples of DNA from Leipzig start arriving in Connecticut. Among them, the star sample from Croatian bone V80. The sequencing machines are working around the clock, sifting through billions of letters of genetic code, trying to figure out the order, the sequence of every one of them. The team at 454 believes it can crack the code within 2 years.
If we can get the complete genome sequence of a Neanderthal, you're looking at 20,000 genes. That's 20,000 potential different pieces of evidence about what happened to them and how their biology worked. It's really a way of giving a genetic sense to what it means to be Neanderthal.
It's the ultimate cold case. A man dies 38,000 years ago. Now, using DNA from his bones, we can retrace the demise of his entire species. Along the way, we may have to rethink some of our assumptions about Neanderthal man. If the DNA shows that our ancestors were sharing genes with him, then perhaps he was more like us, more human than we ever realized.